Hello students, in this video we will derive and understand the integrated rate law expression for the zero order reaction step by step. So let's get started. Let's consider a simple reaction where the reactant R gets converted to product P. Okay. So as we know, for the zero order reaction, the rate of the reaction depends on the zero power of the concentration of the reaction. That is, according to rate law, the rate will be equal to proportionality constant K, concentration of R to the power 0, because it is a zero order reaction. And we know that anything to the power 0 will be equal to 1. So the rate will be equal to the proportionality constant. Okay. Now let's write the rate expression for this reaction. So for this, the rate will be equal to negative, because the concentration of the reactant will be decreasing by dt will be equal to positive for the product, because the concentration of the product will be increasing by dt. Okay, this equation 1 and equation 2 both are rate equations, right? So we are going to equate the equation 1 and 2. So by equating them, we will get dr by dt is equal to positive dp by dt is equal to k. So here, if you notice children, here the terms are different. Here we have R as a term, that is a reactant, and here we have P as a term, that is a product, right? In rate law also we had only the reactant term. So it will be confusing and we can't also do anything with that. We cannot integrate with the P term. So that's the reason we will be removing this whole term, okay? We will remove this whole term and only we will be equating the reactant term and the proportionality constant. Okay, so this is what we will end up with. Okay, now I'm going to rearrange this equation to separate variables. I'm going to take this dt to the other side, also the negative sign also, so minus k dt. Okay, now I'm going to integrate on both sides. By integrating on both sides, we will get dr minus k integral of dt, because k is a constant, so it will come out of the integral sign. Okay, we have a formula that integral of dx is equal to x, right? So by applying this formula, we are going to simplify it. That is, integral of dr will be r and integral of dt will be t plus I, because while doing integration we have to add the integrating constant. Okay, so it is a constant, integrating constant. Okay, now we have to find the value of the constant. So to find the value of the constant, we have to consider and substitute the values. T is equal to 0. That means when the T is equal to 0, the reaction doesn't even start. Okay, if the T is 0, that is when the reaction doesn't even start, then the reactant also will be in its initial concentration, right? The reaction will not be converting into the product. It will be a reactant. It will be in the state of the reactant in the T is equal to 0 when the reaction doesn't even start. So R naught will be the initial concentration. Okay, if we substitute these two values in this equation, we will get R naught is equal to minus K into T, T plus I. So the I value will be equal to R naught. So now we have to substitute this I value in the previous equation. Okay, we have to substitute in this equation. So if we substitute this I value, we will be getting R is equal to minus KT plus R naught. Okay. So now what I'm going to do is I'm going to just rearrange this thing. So KT will be equal to R naught minus R. I'm just rearranging. That is, I'm taking this KT this side and R to this side. That's it. Okay. As we have seen a formula, we are taking this T to the other side. Then it will become R naught by, sorry, R naught minus R by T. So that's it, students. Very simple, right? This is the integrated rate equation for the zero order reaction. That's it. Okay. Now let's plot a graph. Okay. For this, we are going to consider this equation. This equation, we are going to compare it with the equation of y is equal to mx plus c. So if we compare and draw the graph, so this will be the y-axis and this will be the x-axis. So in the y-axis, we have concentration of R, and in the x-axis, we have T. And comparing this equation, we will get m is equal to minus k, which means the slope is negative. If it is a negative slope, the graph will be declining, right? And we have intercept of R naught. That is C is equal to R naught. We have a intercept of R naught. That means the graph. That means the graph is declining. So we will obtain a graph like this, and the intercept will be, this is the intercept will be R naught. So this will be the graph for the zero order reaction plotted between the concentration of the reactant and the time. And this is the integrated rate law expression equation for the zero order reaction. I hope you understood the derivation clearly. If you found this video helpful, don't forget to like, share and subscribe to Chemexcel with Nithi. See you in the next video. Thank you.